I've started the recording.
Hello, everyone. Thank you for joining. We're going to give it one more minute as people are still trickling in. Thank you again for joining. Okay, it is 1:01, so we can go ahead and get started. Hello, everyone. Good morning, good afternoon, good evening from wherever you are joining. My name is Camille Pottinger, and I am a health specialist within the Division of Neuroscience. And I am joined by Dr. Damali Martin, who is the branch chief of the Population Studies and Genetics branch within the division. I would like to invite you to the Minority Health and Health Disparities in Neuroscience webinar series. This webinar series highlights opportunities for NIA grantees and other interested individuals to share research advances, lessons learned, and opportunities in the field. Before introducing the speaker, I would like to let you know that at the end of the presentation, we will allow time for questions. Please submit your questions and your comments to the Q&A box, not the chat box. And Dr. Martin will ask on your behalf. Any questions we do not get to, please feel free to reach out to our speaker directly. Additionally, this webinar is being recorded and we will send out a copy to all of the attendees within the next week or so. So it gives me great pleasure to introduce our next speaker for the series, Dr. Astrid Suchy-Dicey. The title of her presentation is Examination of Vascular and Alzheimer's Dementias in Community-Based American Indians, Lessons Learned from the Strong Heart Study. Dr. Astrid Suchy-Dicey is an associate professor and director of clinical neurosciences at the Huntington Medical Research Institutes, as well as the co-lead of the Data Statistics Methods Core at the University of Washington Alzheimer's Disease Research Center, and the chair of the Neurology Working Group within the Strong Heart Study. Dr. Suchy-Dicey is an epidemiologist focused on health disparities and social determinants in neurodegenerative disease, with a particular focus on brain aging in American Indians and other minoritized populations. She leads scientific operations for the largest population-based longitudinal cohort study on vascular and Alzheimer's dementias in American Indians, with recent program expansions including biomarker and psychometric validations, examination of strength-based features such as psychological resilience and cognitive reserve, and assessment of bilingual learning and education on cognitive aging. And so without further ado, I will pass it over to our speaker for today.
Thank you so much. I'm just so pleased to be here and to have the opportunity to share this work with you all. I am going to share my screen and hopefully that looks okay. I'll rely on Dwayne to let me know if anything looks amiss. But this talk
looks great.
Okay, thank you. This talk, as mentioned, is titled Examination of Dementias in Community-Based American Indians and Lessons Learned from the Strong Heart Study. I wanted to start briefly with a land acknowledgement of the peoples that were here before European colonization and who continue to be here caring for the lands on which I work and have conducted this research, and to recognize the stewardship of those lands by those peoples. And just by way of quick self-introduction, I am a scientist with interest in health disparities and in health justice. As mentioned, I have a background in epidemiology, and I studied at Smith College and at University of Washington. My ethnic background is English and Slavic in Czech. A brief outline of this talk is that I wanted to share a quick overview of background on who American Indians are and terminology, and then to discuss some of the exposures that population and special characteristics that population is exposed to, and then to talk a little bit about cognitive aging and dementia, what is known and unknown with respect to that population, and then talk about some of the aims and methods in measuring conditions and risk factors and protective factors related to those conditions in partnership with the Strong Heart Study, some of the special considerations and accommodations that we made in doing that research, and then some of the study findings so far. American Indian peoples, as of the most recent US Census, number approximately 10 million in combination with Alaska Natives. A majority are living in urban centers now, and a significant proportion have socioeconomic disparities, many of them living below the federal poverty line. There are hundreds of federally recognized tribes, over 570 federally recognized tribes, and these are sovereign nations with independent governance. A brief review of some of the terminology: American Indian, Native American, Indigenous people. These terminology preferences can differ significantly across individuals, across communities, across tribes. Most often, the consensus preference is to use the specific tribal name when referring to a group of peoples. However, American Indian is a contemporary legal term, and in the studies that I'll be talking about, and I use that term, we refer using that term as collectively referring to those tracing ancestry from the original indigenous peoples of the North American continent. And we use that term because it is a term, first of all, that was agreed upon with the tribal partners with the Strong Heart Study, but also because it's a general term that does not refer specifically to any individual tribe, because we have multiple tribes involved. Tribal sovereignty is a concept that's important in working with tribal groups. They have a right to self-governance that is explicitly recognized by the federal US Constitution, with a nation-to-nation diplomacy and autonomy against encroachment by other sovereigns, such as US states. They make decisions on property and citizens with participation and consent of the tribe. And this has a special relevance to data ownership. Data rights and data access agreements can differ by tribe, but usually data ownership is retained at the tribal level. And so research with tribes usually has a tribal agreement where the tribe retains ownership of those data, and they are not the property of the investigators, but rather of the tribe itself. A little bit of background on American Indian and Alaska Natives in terms of life expectancy. It's lower than for non-Hispanic whites and for other groups within the United States. On average, 6 years lower, although there's a wide range across the United States, oftentimes based on state or by county, with some of the worst counties in some of the more rural areas. There are also education, or have been education access and quality disparities that American Indian groups have been exposed to. There was a historical policy of forced enrollment of children, American Indian and Alaska Native children, in schools that continued through the 70s, and even with the last schools closing in the 1990s. These schools had forced attendance, as I mentioned, and had a priority more on cultural assimilation and discipline than on educational quality, with student mortality much higher than any other US group and possibly underestimated. And this is relevant because many current elders are survivors of this boarding school program. There are also healthcare disparities, both in access and in quality of healthcare received. The Indian Health Service provides healthcare based on treaty and constitutional provision. There are 2,000 facilities covering 12 regions of the United States. However, only 59% of the operating costs are covered by Congress. And on average, the spending per enrollee is much lower than the healthcare spending for other US citizens, lower than half. And in many rural regions, there are often limited or no specialty services, including neurology services. And some of these conditions have led to significant health disparities with obesity, with diabetes, hypertension, and coronary heart disease, all much higher than in other groups in the United States, as well as other chronic conditions. There are also environmental disparities. We have looked at a few of these, including environmental toxicants in groundwater and environmental soil. These exposures can be measured in blood and in saliva and in urine. And arsenic, as an example, is present in groundwater from industrial sources. It's more common in some of the more rural regions, such as those where reservations exist, with 29% of water wells in some of those regions exceeding safety levels set by the EPA, and population biomarkers in some of the groups within the Strong Heart study are estimated as higher than any other US group and are consistent with industrial exposures or workers in industrial settings. And even low and moderate exposures have been associated with both cognitive and imaging findings related to cognitive decline. So all of these disparities have led to cognitive health disparities, with American Indians up to 2 times as likely as white people to self-report cognitive decline. And this is based on the self-report in the Burfess study. However, some of the knowledge gaps include that understanding population prevalence of actual cognitive decline, and with investigators indicating that despite all of the decades of calls for action and research, that the aim to ensure health equality is still too far from reality for American Indians and other indigenous peoples in the US, and that a substantial number don't even believe that they will live long enough to develop some of these outcomes. So some of the specific knowledge disparities underlining some of the motivations for our work are epidemiologic prevalence and incidence of dementia in American Indians is not known. Etiology of biomarkers, risk factors, and outcomes, including strength-based predictors, are also unknown. And so we undertook to conduct a population-based study with prospective data collection in order to reduce and eliminate some of the bias and measurement error that records-based data collection might be subject to, and to create a gold standard, detailed, standardized protocol with high quality control, and to enable us to conduct and create a repository of information with potential for valid inference in epidemiologic and etiologic investigation. Our specific study aims for this effort is in a population-based cohort of older American Indians ages 65 and older to conduct that detailed data collection related to vascular and Alzheimer's dementias and brain aging, and specifically to describe the epidemiology of normal function and impaired function, to examine imaging and blood biomarkers, and to examine risk and protective features for those outcomes. Here's a brief study diagram of the Strong Heart study and how our study fits within that larger parent study. The baseline Strong Heart study began in 1989 with the first visit occurring over a period of about 2 years, and they recruited about 4,500 individuals representing about 67% of eligible adults from 13 tribes across 3 regions of the United States. In 2010, when we began our study, 2 of those tribes were no longer participating. And so this study represents 11 of those original 13 tribes across those 3 regions. And of the survivors, we were able to recruit about 87% of eligible participants who were still able and willing to participate. And then in 2017, we conducted a follow-up in the same group and had about half that were able to come back, with most of those losses due to mortality and frailty. Our study at both visits, we conducted detailed magnetic resonance imaging, cognitive testing, clinical examinations, psychological and medical history questionnaire, and then we also adjudicated cognitive status by expert panel consensus. Some of the tenets of this research were to conduct this research, and of all of the Strong Heart study programs are to conduct research using community-based participatory methods, which is an equitable approach to community-engaged research, wherein researchers and institutions collaborate with the partner communities in all aspects of the research. We involve field centers and institutions within field centers that are nested within those communities and partner with those communities. And those field centers also act as mediators with the core and coordinating center of the Strong Heart study. And these groups partner and collaborate to assess health issues, to select methods for evaluating those health issues, to conduct assessments of health issues and risk factors, interpret the data, design solutions and interventions for follow-up studies, and to evaluate the outcomes of those findings. These partnerships, as I mentioned, with the community organizations and the field staff and advisory groups, community advisory groups, include important principles like sustaining community-based staff and investigators who are from those communities, both as representatives of those communities, but also building viable career paths and collective efforts for members of those communities within the research framework, to create a community presence, both with investigators in the community, but community with investigator organizations, holding events and creating a collective culture of a two-way partnership to build trust, and with a principle of listening more than talking, which seems funny to me since I'm talking so much right now. And additionally, it's important to consider cultural appreciation and expression, which can differ by context, what that means, but to hold those principles and to try to internalize those principles as much as possible. We also conducted significant or substantial ethical reviews for this research and for all Strong Heart study research, which can be complex. The Strong Heart study and our sub-study or our ancillary study, which is shortened the cerebrovascular disease and its consequences in American Indian study, or CDCI. So I'll refer to them collectively as SHS CDCI, had more than 10 institutional reviews with different organizations or entities conducting those reviews completely independently of all others. Those all had to be done, in some cases sequentially, where one would have to wait until another one was completed before they could begin. And so this process can be quite lengthy and time consuming. In addition, many institutional or academic IRBs can oftentimes be unfamiliar with tribal review procedures. And so that required oftentimes a lot of education on the part of those involved so that they would understand what the tribal review procedures were. And so that any policies that an academic or institutional organization had wouldn't conflict with the tribal research review or tribal council reviews that we then had to do later. Oftentimes, as I mentioned, some of the research review boards or other review organizations wouldn't review until after funding was received or other reviews had been completed. And some also require live presentations and ongoing review through not only the life of the study, but for as long as researchers retain access and use of the data. And so some of those are ongoing. Even since 2010, we have ongoing review of those activities. As I mentioned, we have review throughout the life of the research program. We review data collection activities before we begin any activities, which is, I think, pretty typical for a human subjects program. We also conduct review during, including approval of all data use at the analysis stage. So any paper project or any analysis project must be approved again. And then after, with approval of all dissemination materials, including papers and presentations, have to go to tribal review at all 3 field centers. And so the tribes also retain rights to receive and approve all communications related to use of their data. So getting back to some of the data collection protocols with our SHS CDCI study, as I mentioned, we did 1.5 Tesla magnetic resonance imaging with radiologist review and software processing for vascular injury, lesions, for atrophy, and to estimate volumetrics. We conducted a detailed neuropsychology test battery covering multiple domains, including some really popular common screening instruments like the modified mini mental status examination and the Montreal Cognitive Assessment, or 3MSE and MoCA. We conducted expert panel-based consensus-based adjudication for cognitive status and for probable etiology underlying that status. We examined self-reported behaviors and medical history, as well as questionnaire for perspectives on things like Alzheimer's disease. And we conducted physical examination with blood and urine collections and standard labs. Some of the special considerations in our data collections, we expected some participant hesitation. And so we employed, as mentioned, staff community members to create familiar faces and to have that community as part of the research program to help participants navigate the research procedures. We tried to limit participant burden, both in terms of the length of the examination, but also to help support them as far as the costs that they may incur as part of participating in the research process. And that can include things like travel for long distances, having coordinators and staff help drive them or to conduct home visits as much as possible. Some of our participants had to travel upwards of 4 or 5 hours each way just to visit the radiology centers and participate in the imaging for this study. And so some of those are really significant costs that may be incurred on the part of participants, and many don't have the ability to shoulder that burden. We also designed incentive structures that may be higher than for other population-based studies, and that is typical for studies in this population. We had to consider the psychological impact of some of our activities. We tried to minimize the office-based procedures and to have the environment be a more familiar environment than a more kind of clinical office, but something a little bit more familiar, and to do things like presenting the cognitive tests more as puzzles than as tests, because saying things like tests can induce test anxiety or educational anxiety and some of those historical traumas on the part of participants, and especially for elders who were present and were survivors of the boarding school programs. We designed examination procedures with feedback from staff and from community advisory boards, and that's part of that two-way listening and two-way partnership. We also tried to provide clinical supports, especially for participants who may not have access to things like hearing aids or may not have reading glasses, from either limited access to healthcare for those conditions, or just may not have remembered to bring those supports with them to their examinations. We also tried to consider the sociocultural perspectives and how those may influence performance on some of the tests. For example, one of the things that we encountered as part of our tests that we did not expect at the beginning, we found that the trail making test, which requires the coordinator or test giver to correct the person taking the test as they make mistakes, so that the mistakes are not sequential and cumulative, but rather individual mistakes. And since we involve community members who are often younger than those taking the test, this created a conflict, a cultural conflict between the instructions and the requirement of the test design and the cultural values of those individuals giving the test to their elders, and a conflict of younger people or community members not wanting to correct their elders and to tell their elders to stop and to do it a different way. And so that conflict or cultural valuation and recognition of those cultural values is an important component in understanding how social and cultural differences can influence test taking. So getting towards some of the findings from the study, there was about 6.7, almost 7 years between the two examinations. As I mentioned, we lost about half of our participants between our first exam and our second exam, and that was mostly losses due to mortality and significant frailty. Some of our population features, as mentioned, our visit 1 participants were all ages 65 to 95, and our visit 2 participants were ages 71 to 94. A majority of our participants were hypertensive, and more than half were diabetic, and a significant proportion also had kidney disease and had high BMI. Some of our cognitive test scores, we found that the cognitive test score distributions were lower than were expected compared with the majority population, or compared with standard cutoffs for cognitive impairment as set by studies in non-Hispanic whites, African Americans, and Hispanic Latinos. The mean MoCA score was just under 19, whereas cutoffs for non-Hispanic whites for cognitive impairment are around 26. And so that was significantly lower. And overall, the scores seemed downshifted with a, not exactly normal distribution, but just generally kind of shifted over. And so we weren't sure if that meant that all of the scores were lower, or if the test wasn't performing in some way in some subgroup of the population. But we did find this effect in all of the tests that we conducted, including also the 3MSC, the COA FAS, and the Waze digit symbol coding test, as well as others. Some of the considerations for measuring cognition and dementia, of course, we're interested in the direct effect of cognitive test performance and how that reflects actual disease and cognition profiles. So that's the green to purple. The actual cognitive status is what we would like to understand, and the purple is what we're able to measure. But then we have all of these confounding or indirect effects in the blue circles there. And those can be influenced by things like social disadvantages, poor quality or poor quantity of education, poor socioeconomic access to resources, psychological health and traumas, things like depression can influence test ability. And then there's practice effect, test anxieties, and then cultural differences in test administration. I mentioned some considerations that may have affected our trail making test. And then there's bilingualism. People who speak another language the majority of the time may have a disadvantage when encountering test instructions or verbal fluency tests in their non-dominant language. And then, of course, there's things like test presentation timing and access to healthcare. And so as a result of those considerations, we decided to undertake review of psychometrics and conduct validity evaluation for these tests. Some of this work is ongoing, but our initial work looking at some of these tests does suggest that interpretation of the summary scores is likely to be valid, both for research and for clinical purposes. And so that is reassuring, suggesting that these summary scores are interpretable. The COA-FAS, which is a test of verbal fluency, had really good summary score interpretation and consistency across test, retest, and stability metrics. We did find that there needs to be better contextualization for things like education quality for baseline ability. We've conducted evaluation of 3MSE, which is that multi-domain test that's usually used as a screener for cognitive impairment. We found that there was good interpretability of the single summary score, and that there were 4 subdomains that did have different interpretability across substrata of the population. So while that main domain had interpretability across the population, subdomains across different groups may not be as directly interpretable. And so we do need to consider contextualization and possibly adaptation for things like age, sex, education, and especially bilingual use. Some of the work is still ongoing for things like MoCA, the Ways Digit Symbol Coding Test, the CVLT, which is a measure of memory, and other cognitive tests, which are still ongoing. However, as mentioned, this suggests that our summary scores are likely to be valid and interpretable. So looking at the prevalence of dementia, using some of these tests to conduct the cognitive adjudications by consensus panel, we found about half of this population to have some degree of cognitive impairment, whether that's mild cognitive impairment or dementia as defined according to DSM-5 criteria, or other impairment which is not within those categories, that falls within some other impairment group. And this is higher than expected, and it's higher than has been found in other populations, with up to 30% in non-Hispanic whites, up to 40% in African Americans, and nearly 40% in Hispanic Latinos. So it is significantly higher. We found, looking at probable etiology, that vascular and neurodegenerative or Alzheimer's type etiologies were roughly equivalently responsible for both mild cognitive impairment and dementia, with Alzheimer's etiology responsible for about 41% and vascular for about 40 to 51%. And so we found that unlike other findings from other populations, vascular etiology is a substantial contributor to some of these and may be part of what's driving that increased prevalence of cognitive impairment. We also found that traumatic injury was a significant contributor, both with 1 to 2% of overall impairment, as well as 12% of that other impairment group. And this is a substantial finding that we have yet to fully explore. Looking at strength-based features, we also have evaluated cognitive resilience or cognitive reserve, which is a concept that cannot be directly measured, but can be estimated or quantified using a comparison of a cognitive measurement above and beyond some status of pathology. And so in this case, looking at this concept initially with an initial evaluation, we conducted regressions of processing speed using the Ways digit symbol coding test against brain volume, just overall brain volume. So a fairly crude metric, standardized to intracranial volume and adjusted for age and sex. So this is only one way to estimate cognitive reserve. But we found that this measure of cognitive reserve was positively associated with higher education, negatively associated with presence of diabetes and depression, suggesting that this is potentially a relevant and legitimate way of measuring strength-based aging in terms of people who are performing better than may be expected, given their degree of pathology or brain aging. And so we intend to continue following this and evaluating this with additional potential measures and outcomes. But in summary, the cognitive findings so far were that our cognitive test scores across this population were overall lower than may be expected compared to other populations, with mean scores below what are standard diagnostic cutoffs used in clinic. We conducted psychometric evaluations, which suggests that the scores are interpretable, but that there's contextualization needed for age, sex, education quality or baseline status, and bilingual status, and that adjudications using these scores suggest that about half of this population may be impaired, with 10% having dementia, and that's 10% of those over age 70. We found that vascular and Alzheimer's etiologies were approximately equally important in this population, and that's high, with vascular etiology contributing to a greater degree than may have been expected based on prior literature. But we did find that cognitive reserve may also be a way of examining cognitive aging from a strength-based perspective. Some of the limitations of this work so far are that the psychometrics are still ongoing, and we have still to evaluate all of the cognitive tests. And we only have one time point so far of really detailed cognitive data at that second exam, and that's in people age 70 and older, not age 65 or even younger. And finally, that we haven't validated these findings to a gold standard of pathology, such as PET imaging. And so those are potential future directions to examine younger groups, to validate this pathology, and to consider additional measures of cognitive reserve, as I mentioned. So moving on from the cognitive findings into some of the more objective or objective and biomarker measurements like imaging, we have also conducted detailed, as I mentioned, MRI and biomarker evaluations in this population, and we found about 2/3 of this population to have a significant amount of brain atrophy, and about 1/3 to have abnormal degree of vascular disease, whether large or small vessel disease. And this is to compare about 40% greater degree of vascular disease than found in other comparable populations of non-Hispanic whites, such as the cardiovascular health study. Some of the findings of MRI image atrophy, we found that intra-individual brain volume loss was about 0.5% of brain per year. We found that hippocampal loss was associated with male sex, older age, with diabetes presence, and with outcomes, losses in memory scores. And we also found similar findings for entorhinal cortex, parahippocampal cortex, and overall brain. And these are regions that are often targeted by Alzheimer's disease and neurodegenerative processes. And so that is the reason that we focused on those particular regions. So I really shortened this, so I surprised myself by jumping straight to the biomarker findings. Some of the findings of our biomarker work so far is that we have found more vascular injury and atrophy than in the general population, and a greater degree of brain volume loss in male sexes, in those with older age, in those with diabetes in particular, and in association with memory scores over time. However, some of the limitations of this work are that we have not looked at atrophy and neurodegenerative injury specific to Alzheimer's disease. These findings are on general structural imaging, and so we don't have that gold standard like with PET imaging that we can look at Alzheimer's specific imaging. And so we need to look at more specific markers to define Alzheimer's disease, such as a complete ATN framework with PET imaging and with potentially some of those other biomarkers. Some of the future directions are, again, to look at younger groups, to look at changes in some of those imaging markers, and to validate that pathology. We are looking at some of that work now and trying to also construct an aging clock to look at comparisons of biological aging with chronological aging and to evaluate risk factors in terms of those comparisons. Finally, looking at part 3, this risk factor component of our work. And this is in context of the Lancet Commission model, looking at some of the modifiable risk features over the life course that comprise an estimated 40% of risk for Alzheimer's disease and other dementias. And those include things from early life, like education, midlife, including traumatic injury, hypertension, alcohol, obesity, and hearing loss, and then late life with smoking, depression, diabetes, social isolation, physical inactivity, and air pollution or other environmental factors. And then genetics being an additional component that is in that kind of risk unknown or other 60%. So coming back to education, which I've mentioned a few times, we looked at education, which is one of those early life markers and risk factors for cognitive decline. Mean education in our population was about 12 years, with most individuals having education between 12 and 14 years. We did find contextually that there was a low correlation of length or tenure of education with a measure of crystallized function or baseline ability, which we use the RAT reading score, which is a measure of ability to correctly enunciate words of increasingly reading difficulty. In the general population, the correlation is with a Pearson's correlation coefficient between 0.6 and 0.7. And in our population, it was less than 0.4. So just over half as correlated. And so that suggests that the correlation in our population is much lower, and that using length of education as a proxy for baseline function may be less valid in our population than in the general population. And so the need to have a better contextual feature when assessing cognition may be important. And this may be due to some of that poor quality education, childhood traumas, test anxiety, and also some of the cultural valuations such as extracurricular learning could be some of the components contributing to this low correlation in this population. Another feature that we have looked at in more detail includes diabetes. Listed in the Lancet Commission model as a late life feature, but potentially in this population contributing even at midlife due to a high proportion of even midlife individuals having this chronic disease. We found in a number of papers that diabetes was associated with cognitive aging, with cognitive outcomes, and with imaging outcomes, including in this analysis of volume loss attributable to diabetes. We found that up to 40% of regional volume loss was attributable to diabetes. In the frontal lobe in particular was the largest degree of volume loss attributable to this condition. We also found similar, although subtler, findings for chronic kidney disease, which in this population is largely attributable diabetic nephropathy to diabetes. And so this suggests that diabetes may be contributing not just in late life, but even in midlife to a significant proportion of neurodegeneration and atrophy, and potentially also to cognitive outcomes that result from that. Another feature that we've looked at includes a significant risk factor in the general population, the ApoE4 risk allele. This is a genetic risk factor for Alzheimer's disease that is one of the strongest risk factors. However, in our population, we detected no association with cognitive test scores or with MRI features or with a measure of memory impairment at all. And this was surprising because it is such a strong risk feature in non-Hispanic white populations. However, other minoritized populations have reported inconsistent or null associations for those groups as well, including African Americans and Hispanic Latino populations. And we did find in subsequent research that there is a very subtle association with some of the plasma markers representing amyloid beta. And so we're still trying to understand why we have such a subtle finding. It may be that there's a reporting bias. We may have a selection bias that has resulted in selective survival, reducing those who are most strongly affected by the ApoE4 gene before we even get to the age of high risk from non-Hispanic whites, and inclusion in this study, they may be getting selected out of the potential study population earlier for this population, or there may be things like excess risk in the unexposed, resilience in the exposed, or undefined gene environment effects that could be contributing to this observed null effect. And so we're still trying to understand these null findings and to contextualize those findings in the face of the prior findings from other groups. Another feature in late life is social support. This is a protective feature in the Lancet Commission model. It's presented as social isolation, a risk feature. Some of the work from our study looking at it as a strength feature, we found that social support can actually even intervene on some of the risk features like depression for cognition and mortality risk, suggesting that this feature may not only be an important risk feature, but may even be a moderator or a mediator of some of the risk features that otherwise exist. And so we are also still trying to evaluate these findings. However, some of the contextual considerations in our population are that emotional and instrumental support and the social network in American Indians and other minoritized and cultural groups may not look the same as in other cultures and other population groups. And so measuring social support across culture groups, across communities may not be comparable. And so we're still trying to understand fully with input from our communities what that may look like in the future. And so we have active programs looking at social support and social networks as protective features for cognitive aging to try to understand that. So just as a summary of some of the I've mentioned a couple of the Lancet model features, a summary of a greater number of those features that we've looked at so far in the Strong Heart study and the CDCI study as an ancillary. I mentioned education, less than 12 years, 46% of our population is exposed to that binary risk factor, which is a little bit higher than in the general population. We also looked at traumatic brain injury, with 31% of our elders being exposed to a history of traumatic brain injury, which is significantly higher than in the general population. Hypertension is much higher at midlife, about 40%. In our elders, it's 80%, and in the general population, it's much lower. However, alcohol use is much lower in our population than in the general population. And so that is potentially a risk factor that is less common in the Strong Heart study and in American Indians than in other groups. Obesity, I mentioned, or high BMI is somewhat more common. We have yet to measure hearing loss. Smoking is more common, depression is more common, and diabetes, I mentioned, is also more common. Some of these other components, social isolation and social support as the other way of looking at it, those are difficult to compare due to potential contextual and cultural differences. Physical inactivity is probably quite high, although we have yet to fully measure that in this group. And air pollution we have not yet measured, but we have looked at environmental exposure to environmental toxicants from groundwater, and those are high. And so that suggests that air pollution may also be high. So just a summary of some of the risk features that we've looked at as part of our study. Education, we need better methods to contextualize baseline function. Midlife, some of the risk features are quite common, although some are uncommon. Late life, many risk features are common, and some may even have impacts much earlier in life course than in other populations, although some of these have yet to be fully measured or to be measured in a way that is relevant to our communities. And so we're still working to do that work. Some of the genetic risk features were not found in our population than in other populations that were found in majority or white populations. And so that suggests that some of those findings may not be generalizable to all groups. So I'm noticing I'm running short on time, so I'm going to try to speed up. An overall summary of our strengths and limitations. This work is population-based with inference to the target population, to the underlying population from which these groups were drawn. It's likely to be generalizable to multiple communities across 3 regions. And of course, this work is longitudinal with detailed, objective, standardized protocols with many variables collected, representing a significant potential for ongoing research in this area. Some of the limitations are that we have some selective survival and attrition over time. Although this group is likely representative of the age group that it's drawn from. And we have still some cognitive test validation ongoing. The structural MRI is not able to differentiate specific pathologies, and so we still do need to collect gold standard for that pathology to be able to fully contextualize to things like Alzheimer's and other pathologies. And there are some important features that may be overlooked or have been measured inadequately. And so we're still working to collect some of that data. Some of our future works in progress, I'll just put this slide here and gloss over so that we have time for questions. because I want to get to the acknowledgements. This is a huge amount of work that I have skipped over a ton of the work that we've done. And it would not have been possible without the significant contributions of our participants, our communities, and field staff. I cannot overstate how much they have contributed to this work, as well as all of the investigators and staff at Washington State University, University of Washington, the Strong Heart Study in general, and our collaborators, and of course, our support agencies at the National Institutes of Health and elsewhere. So I cannot say thank you enough to all of these individuals, and many more that haven't even been able to be listed on this slide. So I would be more than happy to take questions.
Thank you so much. And I second my thanks to everyone who's participated in your research, contributed it to your research. You know, your data is just amazing. And to me, it just emphasizes the importance of looking at the etiology of disease within a minority population, within the context of their environment, without having to feel the need to compare it to, you know, a non-Hispanic white population. So thank you so much for that. That was a fascinating presentation. I'm going to go quickly to the questions. We are going to go up to 2:15.
Sure. I looked at the time and I was like, oh
no. I hope that's okay.
No, it's great. Thank you.
Sure. So the first question is, does tribal ownership of data typically extend to data derivatives? For example, a statistical map derived from tribal members' MR images?
That is a really great question. You know, I think that any information that is collected from tribal members is tribal data. And I think that that would extend to any information that would be derived from that. I think that information that might be, I guess, personally, I would draw the line at collective information. Like if you're creating data on a collective level, that might be different from creating data on an individual level. Like if you're mapping individual image sets, that would be, but I think that that question might be better directed to the tribes. There are, you know, that is potentially where I would draw a line, but I am definitely not an expert in this area. This is an active area of ethics and conversation. This is an active area in particular because it also affects individuals recruited not through tribes, people who are recruited from urban centers who may just be acting as individuals and may or may not have a tribal affiliation. Do they have tribal, you know, governance that has, you know, ownership over their data? And this is an active area of conversation. The National Institute on Aging and National Institutes of Health more broadly are contributing to that. I know that there are working groups with representatives from tribal entities that are working on that. It is largely, I can't say largely an unexplored area, but I know that there's a lot of international law here that has not been written. And so the tribes are also working on policies governing their data and governing tribal data more broadly. And so, you know, I don't want to overstep the bounds of my knowledge, but I just have to say this is an active area of conversation. So, yeah.
Yeah, and the question points to like the complexity of the issue and, you know, the many things that you have to consider.
Great question. Really great.
Yeah. Okay, next question. Have you considered virtual visits in lieu of in-person visits? And I guess that's in relation to the 4 or 5 hour travel. This may reduce participant burden, psychological impact. Some tests have correlates. Example, the oral trail making test instead of the trail making test, but normative values are not the same, so that could be an issue.
Yeah, I think that's a really great suggestion. Definitely we have considered it and talked about it. it becomes difficult when you have remote populations who may not have consistent access to networks, like internet networks. There are parts of the country that don't have good or consistent access to internet, good or consistent access to devices that serve internet. And so doing virtual visits, especially when you need video, may not be possible for some peoples. However, for some, it is a great solution. And so, we are working on a visit proposal for a third visit and hoping to propose home visits or a greater component of home visit for those who have aged into frailty, or who have, moved into frail condition. And we think that it's a good solution to help those individuals to participate. But, I think that when possible, telemed or similar is a great way to surpass those boundaries. Yeah, I mean, whatever is possible.
Yeah, absolutely. Okay, our next question. Was an analysis of literacy included? And I think the person is referring to Dr. Manley's work showing that in Black people, literacy is a more valid assessment of educational attainment than years of school, given the poor quality of education in rural South or dense urban areas.
Yeah, that is a very good question. I don't know if there was a formal evaluation of literacy. However, being able to read and write was a component of participation in the Strong Heart studies. The participants do fill out their own questionnaires. And so there is, I think, a degree of, and I didn't mention this in part because I just really limited the amount that I could squeeze into this presentation.
Yeah.
Fluency in English was a requirement of participation in the original Strong Heart study, and some degree of literacy, able to read and write and participate in, taking a questionnaire were, conditions of participation. And so I think all of our participants are to some degree literate, but I don't know, if there's like some kind of continuous measure of literacy. I don't know of that. I would think that could potentially be a sensitive topic that would best be handled carefully. So, I haven't seen it addressed. I haven't seen those data, if they were collected.
Yeah.
But I think that's a very good suggestion. Yeah, as I think that, the RAT reading score and other RAT tests are similar measures. They're not exactly literacy, but it's an ability to read increasingly difficult words. And they start from very, very easy words like cat, hat, and it gets into things like, I don't know, segue and Greek root words that are challenging. And so there's something like 60 words, and most people, even people with a college degree, get, somewhere in the middle, and it's designed to be difficult. It's designed for people to fail at some point. And it tends to be a fairly sensitive measure of educational quality. We have only given the RAT reading test, but on NIH Toolbox actually has a few measures of crystallized intelligence or baseline function. And we're administering the NIH Toolbox to this population in a project now. And we're hoping to have a better measure of those data in the next few years. So maybe I'll have a better answer someday.
Okay. Well, there is a related question to that, because anonymous submitter wanted to know what the percentage of participants had English as their primary language.
Primary language, I think about, at a guess, it's about a third, maybe 25% to a third, speak their native language at home or primarily, but all can speak English fluently. So that's more of a preference or a home life reflection. They're all fluent in English. And so those that speak their native language or another language at home, those are bilingual individuals. And then another 40% or so speak their native language at least moderately well. And so we had at least half, I think between around 50 to 60% were at least, some degree bilingual. That's
Okay.
from my memory.
Yeah.
I apologize for not having that.
Oh, no, that's okay. I'm curious about something. So right now there, through the health and retirement studies, there are a series of international studies where they're trying to harmonize data and use different surveys with different languages. Has that ever been explored, or is that something that you're planning to explore using the indigenous languages?
It's like you're plugging for our ongoing projects. We have a looking at bilingual status and we're actually planning to adapt a measure, like an instrument evaluating history of bilingualism and bilingual lived experience. So it's more about their experience at speaking multiple languages and speaking different languages and their history and learning and component, so it's kind of more identity and history. Adapting the components, especially the cognitive tests, to indigenous languages would be tough because there's hundreds of them. There's dozens even just within our study alone. So I think that would be a huge undertaking because it's not just a matter of translating, it's also cultural components and how things are viewed. And so I think that would be really hard to do. That doesn't mean that it shouldn't be done. I think that, I'm not probably the person to speak about that, at least not yet. Not until we're able to understand the bilingual experience, but we're hoping to understand better some of that lived experience and to evaluate different components of that lived experience in association with performance on cognitive testing and see whether there are different components that are more predictive with risk and protection, and to try to piece that apart a little bit.
Yeah, great.
Thank you for
Okay,
asking.
yeah, no problem. A question from Tina Jimenez. So cognitive reserve in the study reference education as a protective factor. Are there any culture-specific factors that have identified as protective factors in relation to reserve, as the quality and quantity of education can be a huge barrier when considering social determinants of health?
Yes, really, really good question. So the Cognitive Reserve Project is in its infancy. We've only done that one analysis so far, and are hoping to expand to other ways of measuring cognitive reserve. We have a program now looking at cultural and identity features in relation to psychological resilience and protective components of cognition, and we're hoping to look at those in relation to cognitive reserve, and especially with what we find to be the most likely and best measures of cognitive reserve in this population. So we're hoping to evaluate the best measures of cognitive reserve first, and then to evaluate those when we're done with the data collections now, with those identity and cultural features. But to give you a short answer, not yet. We're hoping.
Okay.
Yeah.
Lots to come.
Yeah.
Okay, another question from Silas Hayes. Was cerebrovascular injury mediated by strong prevalence of hypertension?
It was difficult. So hypertension is associated with vascular brain injury in this population, as evidenced by the imaging, but it was difficult to look at it with high power because so many people are affected by hypertension that we really had limited ability to look at mediation models, to look at it as a mediator for cognitive outcomes, because there's very little variance. So many people are affected. We just don't have a lot of, and so I think that a future direction, my hope is that we can look at a younger group before so many have hypertension, and then have a greater degree of variance in that feature and be able to look at that question. And so basically, I think we have to get in front of it, look at the population before that outcome, before it's saturated, essentially.
Okay, great. Another question, cognitive resilience, also referred to as cognitive reserve, was defined using one measure of cognitive performance, processing speed, and brain measure. Usually cognitive reserve is composed of performance on cognitive tests, pre-morbid functioning, and other engagement access to enrichment activities, while brain reserve takes brain measures into consideration. Can you talk more about how you choose to quantify cognitive reserve, why the variables selected were included, and whether you think the results might change with a more comprehensive cognitive reserve measure?
Yeah, that's a great question. And I think the short answer is we chose processing speed because it is the strongest association with aging and decline over time. And we chose brain volume because it's a general measure of overall decline in brain health, and has a consistent linear change over time as well. And so they're both kind of insensitive, but strongly related to change over time and change with age. And so we selected them because they're not particularly specific, but have that strong decline, because we wanted to look at an initial view. And so I think what you're getting at is there are better measures, and that is very most likely correct, that there probably are better measures. And that's our follow-up, is to look at and define what those better measures are and what those more specific measures are. Maybe there's a measure of cognitive reserve that could be defined that's more specific to neurodegenerative injury, whereas there's one that may be more specific to vascular injury. I don't know. This is an area that I think is evolving quickly, and we are just getting started looking at it in this population. As far as brain reserve, I think that we need better measures of the brain pathology before we can really get into looking at that. And so, you know, the other measures of cognitive resilience, like brain maintenance and brain reserve, I think we're going to need to get into those as well. But
okay.
It's a good point, and I totally agree. Yeah.
I think we have time for a few more questions. And I'm so sorry if I don't get to your question. Lance Suchy asks, what associations, if any, have you found with ApoE2?
ApoE2, yes, we did. It's a good point. We looked at carrier status of ApoE4. And the reason we did that was because there were so few ApoE4 double carriers that it would essentially not be possible to look at double carriers. It was essentially an analysis of 3-4 versus 3-3. There are some E2 carriers, and we haven't looked at that, but there aren't very many in this population. And so I haven't done that analysis yet. I think that we should. Yeah, I think we could do a more sensitive analysis of the, full genotype, but we were limited in power, essentially.
Okay, all righty, great. This next question is from Jennifer Manley. Wonderful talk, wonderful in all caps. Do you have a plan for addressing survival bias in the surviving cohort?
Yes, really good question. In this cohort, we're limited to sensitivity analysis, looking at things like using inverse probability weighting methods. We do have a program using Bayesian methods to try to evaluate things like survivor bias and try to improve on the methods. We would like to look at a younger group before, potentially, if survivor bias is operating, to look at them before they're removed from the population essentially before that risk group, that a high risk group is removed. We are recruiting individuals that are younger and looking at cognition and risk features now. And so we're hoping to be able to evaluate with a greater degree of sensitivity how much we think that survivor bias and attrition is likely to have operated. We did look at bias from the initial exam from 1989 to the 2010 exam on the basis of vascular features. And we found minimal bias among those who did and did not survive to participate in our first cognitive exam. On measures that, on features that were measured at both exams. However, we looked at bias between our first cognitive exam and our second exam, and we found significant loss and attrition between those exams. And so we think that essentially mortality and attrition, unsurprisingly, is accelerating. And so people or analyses that are focused on inference, that look at change between our two cognitive exams, will need to use those methods to address potential for bias. However, we don't think that there's significant bias from the original exam, at least not on the basis of vascular measures.
Okay.
It's an active area of research, and I think a lot of opportunity for methodologists to get involved. So if you have interest, email me.
I think you're going to get a lot of emails. So a related question to this is from Dallas Anderson. Do you see any value in conducting a Gen 2 study?
Oh, you mean a generation?
I guess a second generation, maybe looking at the general,
Yes, I do see it. Yes, we would like to do the third visit in this same group so that we can look at a better trajectory over time. And, you know, I didn't really go into this in detail, but we collected more measures at our second exam than we did at our first exam. And so we would like to collect the expanded battery again. But I do think that it would be valuable to conduct imaging, to conduct a cognitive battery, to conduct a lot of this work with validated pathology and ATN measures, and maybe even the expanded IVS ATN matrix in a younger group, in those ages, ideally 45 and older, but certainly 55 and older, because of that potential for survivor bias, because I think this confluence of risk factors is potentially, you know, causing vascular brain injury and removing individuals from the group before they even make it to the age 65, you know, conventional high risk.
Yeah. Okay, one last question, because I feel this one is a really good question too. Has there been any consideration of adding a component pertaining to brain donation? The reason why I wanted to ask this is I'm reminded of the Smithsonian's collection of brains that were unethically collected, many of those brains from indigenous populations. And here we are today trying to do this research and trying to collect what I consider an important component of the research. And this question was raised by Karen Ward. So,
Yeah, that is a very good question. We have not asked participants whether they would be willing to donate their brains. However, and you know, I can't speak to why the Strong Heart study has or has not chosen to address that. However, in general, brain donation and organ donation in general is a sensitive topic for many groups, many culture groups, in part because there's, and I don't want to get too deep into this because this is not my culture, but, so I don't want to speak on other people's behalf, but my understanding is that there is a cultural value of meeting your maker, meeting the creator intact, and not wanting to go to the creator without important components of your being. And so that is an important consideration when thinking about things like organ donation or and especially brain donation and autopsy.
Yeah.
That said, there's also a significant value of protecting community, being an ancestor, and thinking about what you can do to serve your descendants, your community, your people. And that's also a very important value. And people have, our research group at Washington State University and iReach has done some research in this area, and I know others have as well, and consulted with Indigenous peoples and Native tribes and asked them, if this was a benefit to your community, would you be willing to do brain donation? And many of them have said yes. So I don't think the automatic answer is no, but I think it has to be done from a culturally grounded perspective that is in line with, the values and consistent with the values of the community. And, not just, please give us your brains, but rather, this is something that we partner with you and that is done with the tribe and from the tribe. And so, my suspicion is that it's possible, but I think that would be an undertaking that would have to involve communities for sure.
Yeah, for sure. Well, thank you so much again. This was so wonderful to have you join us. I'm always just amazed by your data, and we hope that sometime in the future we will hear more from you and from your study. And learn so much more about this population that's really understudied in AD research. So thank you once again. And thank you to all participants, especially those of you who hung in there with us to the very end. I just wanted to let you know before we sign off that our next presenter will be in April, and it will be Dr. Sid O'Brien, who's going to talk to us about the HABS HD study. So we hope that you will come back and join us again. So thank you once all again. Have a great day. Thanks again, Astrid. Take care.
Thank you.
Yes, we will see you soon. Bye-bye.